Hi everyone, so let's see this topic now, very important topic. You need to implement logical expression using MUX. So for gate examination it is also very important, like in every year if they are asking questions from the MUX, then they will certainly pick this topic only. So you need to implement logical expression using MUX. So there will be two kind of cases. In first case, number of variables that I am denoting as n, number of variables will be equals to the number of select lines. And here number of variables will be more than the number of select lines. Here you will solve it by using minterms, here you will make implementation table, and this I have written input of the MUX will be either 0 or 1, this also you will understand. So no need to mug up this table or anything, just see the examples and then you will be able to understand everything. So this is the first one, you need to make a bar, so this we already know. So here 0 should come and here 1 should come, this will be our a bar. How many number of variables are there? 1. How many select lines are there? 1 only. What are the input? Either 1 or 0. Let's make this one. F is equals to AB. Number of inputs are 2. Number of select lines are 2. So select lines, number of select lines are 2. So in select lines I will put A and B. I will put A and B. In select lines I am putting A and B. This is your I naught, I1, I2, I3, and this will be your output Y. Now I know A bar B bar is, when A bar B bar comes, this should be 0. When A bar B should come, this should be 0. When A B bar comes, this should be 0. And when AB comes, this should be 1. So that my output is AB. Or how I should have solved it using minterm. So F is equals to AB. So what is the minterm for this? M3, right? So M3 is there, so only I3 should be 1, rest all should be 0. Basically, what is your Y? Y is A bar, B bar, I naught. Again, I am writing everything. A bar B I1 plus A B bar I2 plus A B I3. So A bar B bar is M naught. A bar B bar is M naught, right? A bar B bar 0 0. It is M naught. M naught I naught plus M1 I1 plus M2 I2 plus M3 I3. You need only M3 to be 1. You need only M3 to be 1. That's it. Your Y should be equals to, you need Y equals to I3. Sorry, you need only I3 equals to 1, not M3. You need only I3 equals to 1. Rest all should be 0. So Y should be equals to M3. For that, your I1, I2 and I naught should be equals to 0 and I3 should be equals to 1. So that's why I put this in this one. So what you can do, you directly write down the minterms. M3 minterm is there. So only I3 should be 1, rest all should be 0. That's it. That's all other question. What is F equals to AB? What all minterms are there? First thing is that you will see number of variables that are 2, A and B. How many select lines are there? 2 select lines are there, right? So you can solve it by using minterms. So how many minterms are there? What is this? What will be the minterms for this? F is equals to AB. F is equals to, A plus B. F is equals to A plus B. I can see that max term is 0 because A is 0, B is 0, so max term is 0. So what will be the minterm? Minterm will be 1, 2, 3. Minterm will be 1, 2, 3. So 1, 2, 3. These will be 1. And these will be 0. That's it. You can check here as well. Like if A bar B bar is coming, 0 should come. That means it will not come. Basically A bar B bar into 0 plus A bar B into 1 plus A B bar into 1 plus AB. So here you can see this is 0 and A bar B as it is. You take A as common. So if I take A as common, so B bar plus B will be 1. So A plus A bar B, that would be equals to A plus B only. So just write down the minterms. You get to know 1, 2, 3 are the minterms. So these will be 1s, rest should be 0. That's it. Okay. What are the minterms for this? Do you need to make K-map? This is a very famous expression. What do we call it? When we study half adder, it will again come to us. Okay. So what all are the minterms for this? 3, 5, 6, 7. This is majority number of ones detector. If you remember it, majority numbers of ones detector. So 3, 5, 6, 7. You can derive it using K-map, but minterms are 3, 5, 6, 7 only. Or you can derive it using this A, B, C bar, C. But I told you this is a very famous expression, so we need to remember it. This is a self-dual function. And there are other expressions as well, which we will write down. So we will see that this is a very famous one. So 3, 5, 6, 7. 3, 5, 6, 7. Rest all will be 0. That's it. This is how you can write your output. Here also number of this will work only if number of variables and select lines are equal. Number of variables and select lines. So this is the first thing you need to check. Here number of variables are 4 and select lines are also 4. So that will work. So that method of minterms would work. So all here you will get 1 or 0. So let's check what all minterms are there. So I will do it using K-map. C, wherever you see is there, you can get the minterms right like this, right? C bar, D bar, C bar, D bar, ABD, ABD, ABD. That's it. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So all these will be 1. 0 will be 1, 2, 3, 4, 6, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this will be the input. In the examination, you will not be doing sir A bar, B bar, C bar, D bar. No. Just get them in terms, put these values. Now you will say, sir, how they will ask in gate examination, because in gate examination MCQs should come. They can ask these values. No, in option they will put I0 will be equals to 1, I2 will be equals to 0, I3 will be equals to 1. So these kind of things they can put in the options. Then you need to pick one of the option. And in the interview they will ask you to do the design. Now see this question. How many variables are there? 3. Using 4 cross 1 MUX, how many select lines are there? 2. So now interesting thing will come. So here number of variables are 3, select lines are 2. So here what you will make, implementation table. Okay, so now you need to make implementation table. So I will just make a rough 4 cross 1 MUX. So these will be the select lines and these will be the inputs. Inputs will be 4, I0, I1, I2, I3, and one of the output will be there. We will be again and again using this 4 cross 1 MUX. 4:1 MUX. I0, I1, I2, I3. Select lines are S1, S0, and this is your output Y. So let's see the first question. In first question, you need to take AB as a select line. So how will you proceed in these kind of problems? AB as select line. So select lines are AB. So now these are not in our control. What is in our control? Function is of ABC. So AB are the select lines. They will take their value 0, 0, 0, 1, 1, 0, 1, 1. So AB is not in our control. In our control, C is there. So I will write C is equals to 0 and C is equals to 1. What all inputs are there? I will write I0, I1. You will realize why I am doing so. I2 and I3. Now, how will you get I0 when AB is equals to 0, 0? How will you get I1 when AB is equals to 0, 1? Right? Because A is MSB. When AB is equals to 1, 0 and when AB is equals to 1, 1. Now, A is equals to B, sorry, A, B, C. A is equals to 0, B is equals to 0 and C is equals to 0. That means this will show minterm 0, right? This will show minterm 0. A is equals to, in this row I am going. A is equals to 0, B is equals to 1 and C is equals to 0. This will show minterm 2. Look, for this C is equals to 0 and AB is equals to 0, 1. For this AB is equals to 1, 0 and C is equals to 0. So this will show minterm 4. Say yes or no? Because in the function this is your MSB and this is your LSB. So in that manner only I am writing here. So 100 will show 4, 110 will be 6, 100 will be 4, 101 will be 5, 110. Sorry, some error I am doing. Sorry. This would be 001. Really sorry. 001, 001, 001. So this will be 1. What about this? 011. This would be 3. So now I can see a pattern 0, 1, 2, 3, 4, 5, 6, 7. This is how it will be repeated because AB 1, 1, 1. So whenever you are writing down these values, no, you will see a pattern. 0, 1, 2, 3, 4, 5, 6, 7. So this is the pattern. Now what all minterms are there which I need to find? What all minterms are there? 3, 5, 6, 7. 3, 5, 6, 7. So I will mark on 3. I will mark on 5. I will mark on 6 and I will mark on 7. What does that mean? That from here only C should come. Here is marked, no? This is marked here. So that means C should come because C is equals to 1. Here C is equals to 1. From here as well only C should come because C is equals to 1. Here C and C bar both will come. If there is a mark on both, that means it should be 1. C plus C bar should be 1. And here there is no mark, so this should be 0. So I0 value should be 0. I1 should be C. This should be C and this should be 1. You can check it out. You can check that out. What that would you look? This is the method. This is the way we solve. C is equals to 0, C is equals to 1. I0, I1, I2, I3. AB is equals to 0, 0, 0, 1, 1, 0, 1, 1. Okay. Write down the minterms 0, 1, 2, 3, 4, 5, 6, 7. What all minterms you need? 3, 5, 6 and 7. So 6 and 7 both you need. That means C plus C bar you need 1. Here only C you need because this represents C and this will represent C bar, right? In minterms. So C only. Here C only and here nothing is there, so 0. So this is how you need to write it and you can check it. So what will be your Y? Y will be A bar B into C plus A B bar into C plus AB. So here you can see AB will come as it is and C I can take common, so A bar B plus AB bar. So AB plus C A XOR B. This is your Y, right? And Y is same only because we have seen this in our first lecture that it can be written as AB plus BC plus CA, right? This we have already seen in our first lecture itself. Did I tell you this or not in the first lecture? I hope I have told it as far as I remember. Yes, I remember I have told it. AB plus CA XOR B can be written as AB plus BC plus CA. There are other expressions as well. It can be written as A plus B into B plus C into C plus A as well, right? There are a lot of expressions. Let's solve the next problem. Not next problem, sorry, next part of this. You need to take BC as a select line. So select lines are BC. Select line is BC. So what is in our control? In our control, A is in our control. So A is equals to 0, A is equals to 1. I0, I1, I2, I3. BC can take 0, 0 value. If it takes 0, 1 value, it would be 1. If it takes 1, 0 value, it would be 2. If it takes 1, 1 value, it would be 3. And B as MSB, C as LSB. So B as MSB, C as LSB. Basically select line. In select line, B will be MSB and C will, this will be S1, this will be S0. This is what they are saying. Okay. Now 0, 0, 0, 0. 1, 0, 0. This is A is 1, B and C are 0. A, B, C. A is 1, B and C are 0. So 4. A is 1, sorry, if I go in this one. So A is 0, B is 0, C is 1. So this would be 1. What about this one? A is 0, B is 1 and C is 0. So this would be 2. So pattern I can see 0, 1, 2, 3, 4, 5, 6, 7. Hey, let's check for this. So A is 1, B is 1 and C is 0. So 1, 2, 4, this is 6 only. So 0, 1, 2, 3, 4, 5, 6, 7. This is the pattern we have seen. Now 3, 5, 6, 7. No? 3, 5, 6, 7. So 3, 5, 6, 7. So again the same thing we are getting. Let me check back again. 3, 5, 6, 7. Okay. So I1 should be A, I2 should be A, and I3 should be 1, and this I0 should be 0. So if I make it in this manner, BC as select line, and 4 input lines will be there, and 1 output line will be there. So starting from I0, I1, I2, I3. So 0, A, 1. That's the answer. Let's solve the third one. You should solve on your own. CA as select line, where C is the MSB. C is the MSB of the select line. For the function MSB is A only. For the function MSB is A only. No one is changing it. This is the LSB. But CA as the select line, where C is the MSB and A is the LSB. So this would be your C. This would be your A. Okay. So what is in our control? B is in our control. So B can take 0 value. B can take 1 value. I0, I1, I2, I3. So CA 0, 0. CA should be 0, 1. CA should be 1, 0. And CA should be 1, 1. Then only you will get I3. Okay. Now for this ABC all are 0. So this will be 0. What about the next one? A is, I am checking here. Okay. A is 0, B is 1, and C is 0. So this is 2. Now I am checking here. So A is 1, B is 0, and C is 0. A is 1, B is 0, and C is 0. So that would be 4. I am checking here now. A is 1, B is 1, and C is 0. So 6. I cannot see any pattern yet. 0, 2, 4, 6. No pattern is there. Let's check for this one. So A is 0, B is 0, and C is 1. So this is 1. Let's check for this one. So A is 0, B is 1, and C is 1. So this would be 3. So there is no such pattern here, right? 0, 2, 4, 6, 1, 3. No such pattern. This would be 1, 1, 1. So this would be 7, and this would be 5. We can check here as well that A is 1, B is 0, and C is 1. So 1, 2, 4, 5. These are the minterms. Minterms I have written in ABC manner because our function is defined as this, where A is the MSB and C is the LSB. Now what do I need to mark? 3, 5, 6, 7. Again the same answer. In everything we got the same answer only. B, and this would be B, and this would be 1. So 0, BB, 1. Same answer should be there as well. Why it should be there? Because if you clearly remember, our F can be written as AB plus C A XOR B, or it can be written as AC plus B A XOR C, or it can be written as BC plus A B XOR C. So same expression only you will get. No? So for this, luckily all the expressions are same, but it will always not be same. Let's see this example. A, B, C, D. These are the minterms 0, 2, 4, 5, 7, 9, 11, 13, 14. Using 8 cross 1 MUX. So here, how many numbers of variable is there? 4. How many select lines will be there? 3. So what is the select line? B, C, D. So A is in our control. A can be 0, A can be 1. I will write I0, I1. How many select lines will be there? 7, no? Sorry, not a select line. How many inputs will be there? 7 input will be there because it is 8 cross 1 MUX. So I2, I3, I4, I5, I6 and I7. So BCD, these are the values of BCD. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So 0, 0, 0, 0, 0, 0, 0, 0, 1, 1. This would be 2. This would be 3. This would be 4, 0, 1, 0, 0. This would be 5, 0, 1, 0, 1. 6, 7, 8, 9, 10, 1, 0, 1, 0. 11, 12, 13, 14 and 15. So 0, 2, 4, 5, 7, 9, 11, 13, 14, right? So here what will come? A bar. Here what will come? A. Here what will come? A bar. A bar, 1, A bar. So that's the way we need to solve it. So if I make 8 cross 1 mux here, S1, sorry, S2, S1, S note, B, C, D as select line. So here they did not mention which is MSB, so I am by default taking this as MSB and this as LSB. Okay, they did not mention it, and these will be the inputs: I note, I1, I2, I3, I4, I5, I6, I7. So starting from I note, A bar, basically I note, here you can see it is A bar, here you can see it is A. So A bar, A bar, A bar, 1, A bar. That's it. That is it. Okay. Let's see the next one. Number of variables 4. Select lines. Oh, wait a second. ABC as select line. I forgot this one. ABC as select line. So I need to add a page. So ABC as select line. Second one is ABC as select lines. So what is in our control? B is equals to 0 and D is equals to 1. I note, I1, I2, I3, I4, I5, I6, I7. ABC 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So this will represent 0 only. What this will represent? 0, 0, 1, 0, 0, 0, 1, 0. This will represent 2. What this will represent? 0, 1, 0, 0. This will represent 4. So better I should go here. 0, 0, 0, 1. This will represent 1. So in this manner we are going. What this will represent? 0, 0, 1, 1. This will be 3. ABC is 0, 0, 1 and D is 1. So this will be 3. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 0, 1, 2, 3, 4, 5, 6, 7, 12, 13, 14, 15. So what all I need to mark up? 0, 2, 4, 5, 7, 9, 11. 0, 2, 4, 5, 7, 9, 11. 0, 2, 4, 5, 7, 9, 11, 13, 14. 13, 14. This will give D bar. This will give D bar. This will give 1. This will give D. This will give D. This will give D. This will give D. This will give D bar. Okay, very, very important topic I would say. So like they will ask what should be the value of I3, what should be the value of I5 to implement this particular function. So it can take a lot of time, but if you solve by this method, it will not take much time there. Okay, so just solve it by this method. Let's see the next one. Number of inputs are 4 and select lines are 2. So you can do it on your own. You can still do it on your own. So now you are having 2 select lines and number of inputs are 2. So CD is a select line. Basically this is your MUX, which is 4 cross 1 MUX. So CD is the select line where I will assume C as MSB, S1 S note. I will assume C as MSB and D as LSB. So what is in our control? AB. AB is in our control. Now in the previous cases, D can take 0, D can take 1. But now AB can take 0, 0. AB can take 0, 1. AB can take 1, 0. AB can take 1, 1. And 4 inputs will be there, which will be I0, I1, I2, I3. What about CD? So CD can take 0, 0, 0, 1, 1, 0, 1, 1. So ABCD is our function where A is MSB here. So 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 2, 0, 0, 1, 1, 3, 0, 1, 0, 0, 4, 5, 6, 7, 1, 1, 1, 0, 0, 0, 8, 9, 10, 11, 12, 13, 14 and 15. In this manner we are going. So 1, 3, 4, 6, 8, 9, 11, 12 and 14. Right? Yeah. So what you are getting here? You can write down that it is, sir, A bar B plus A B bar plus AB. Or you can say it is A plus B only. Look, if these are the minterms 4, 8, 12, then what will be my max term? Max term will be this. What is that? A plus B only. Or you can solve it, you will get A plus B only. What about this? This would be A bar B bar. This would be A bar B bar plus A B bar. So it would be B bar only. A bar B bar plus A B bar. It would be B bar. What about this? A bar B, A bar B, A bar B plus AB. What you are getting? B only. And what about this? A bar B bar plus A B bar. We are getting B bar only. So these are same. What about this? A bar B plus AB. A bar B plus AB. So you will get B only. And here you are getting A plus B. So what is the input? How will you define the inputs now? So I0, I1, I2, I3. So CD is there. So I0 is A plus B. I1 is B bar. I2 is B. And I3 is B bar. So that's how you will make it. And in the examination, they will ask like this. These kind of minterms are given. What will be the value of I1, I0, I2 and I3? Take AC as select line. You are taking AC as select line. So BD is in our control. So BD is in our control. So BD is in our control. So BD can take value 0, 0, 0, 1, 1, 0, 1, 1. Right? And I0, I1, I2, I3. What about AC? 0, 0, 0, 1, 1, 1, 1, 0. Right? So 0, 0, 0, 0 will be 0. Now A, B, C, D is our function. So in this, if I go here, so here A is 0, C is 1, B is 0, D is 0. So it would be 2. So this is 2. A is 1, B is 0, C is 1, D is 0. 1, 2, 4, 8, 10. Not getting any pattern. Let's move in this direction. So A is 0, B is 0, C is 0, D is 1. 1. Okay. If A is 0, B is 1, C and D both are 0. 1, 2, 4. 4. Again not getting any pattern. Let's move here. So that would be A is 0, B is 0, C is 1 and D is 1. 3. So it seems like that I am getting some pattern here, 0 1 2 3. So if I expect 5 4 5 6 7, is that correct? Let's check that. Let's check this point, what that would be. A is 0, B is 1, C is 1 and D is 1. Yes, 7 I am getting. So certainly this is the pattern. So I have got some pattern here, 10 11 12 13. Let's check this 12 now. So here A is 1, B is A is 1, B is 1, C is 1 and D is 0. This is 10. So how did I write this as 10? In I2 there is some error, I guess. If A is 1, okay, this is 1 1. If A is 1, B is 0, C is 1 and okay. Here what is the scene? A is 1. Oh, this is the opposite, no? What I am doing? This is 1 0 1 1. 0 0 0 1 1 0 1 1. So let's check back again. A is 1, B is 0, C is 0, A is 1, B, C, D all are 0. This is 8. So 8, 9, 10, 11. This is what I can expect. So let's check this. So A is 1, B is 0, C is 1, D is 10. That is correct. So 8, 9, 10, 11. 8, 9, 10, 11. 12, 13, 14, 15. So some pattern I got, and because of that I was able to write down quickly. But otherwise I would have to spend a lot of time. Let's check for this 13. So for this 13, A is 1, B is 1, C is 0 and D is 1. So 13 only. Yeah. 1 3 4 6 8. 1 3 4 6 8. 9 11 12 14. 9 11 12 14. What you will get here? B bar D plus B D bar, that is B XOR D. Same goes here, right? B bar D plus B D bar, B XOR D. What about this? B bar plus D bar, say yes or no? Or I can write B D bar. How did I do that? BD is equals to 1 1. I am writing max term here, B bar plus D bar. Or you could have written B bar D bar plus B bar D plus B D bar. So what you would get here? B bar plus B D bar. So what you would get? B bar plus D bar only. But directly I wrote here B bar plus D bar. And here as well the same, 11 14. 11 14. So here as well B XOR D. So at the 3 inputs you need to put B XOR D. So this will be your final design. Four cross 1 mux is there now. So only 2 select line which are AC. Select lines are AC. And this is I0, I1, I2, I3. So B XOR D, B XOR D, BD bar, B XOR D. So the output will be these minterms only. Okay. So this is how you need to solve these particular problems. So I hope you must have understood the point here, how we are solving these kind of problems. So just we are writing A and B value and BCD values. A, B, BCD value. So in that manner we are going. And if number of variables and this select lines are equal, then it is very easy. Now this is the final conclusion point. What is that? So there is an important conclusion we have understood. Look, let's just say there is a MUX and I am having 3 select lines A, B, C. So now using this MUX I can implement any function. Why so? because I have A as well, and this mux has the capability of giving me A bar, this mux has the capability of giving me B bar, and this mux has the capability of giving me C bar. Using only one mux, using only one 2 to the power n mux, I can make any n variable function. Say yes or no? Because this mux can give me A bar, this mux can give me B bar, this mux can give me C bar. Everything is about, like, what is the problem? Problem is NOT gate. If you can get the bar, if you can get 180-degree phase shift, no, that is the best thing in electronics. So if you can get a bar, then you can implement any Boolean expression. So if I am having 3 variables and 2 to the power 3:1 mux, then I can implement any Boolean expression. So if this statement is written, what you will think? Okay, you are having 2 to the power n cross 1 mux. That means you are having n select lines. And if you are having n select lines, it can give you the bar of n Boolean. It can give you the bar of n variables. You are having n select lines, so it can give you the bar of n variables. So you can make any n variable function. You can make any n variable function, right? Now using 2 to the power n minus 1 mux, let's just say I have a mux of 4:1. I have the mux of 4:1. So there will be 2 select lines. Here I can put AB input and AB select line, and in one of the input I can put C. So I can get the function of 3 variables. I can get the function of 3 variables, but I cannot generate C bar. So to generate C bar, I would need a NOT gate. If I am having a NOT gate, then I can generate C bar. I can surely generate A bar. I can surely generate B bar as well. So I can have A, B, C. I can have A bar, B bar, C bar. And if this is I am having, I can make any n variable function. So if I am having 2 to the power n minus 1 mux and 1 NOT gate, so if I am having 4 cross 1 mux and 1 NOT gate, then I can implement 4 can be written as 2 to the power 2. Then I can implement 2 plus 1, 3 variable Boolean function. Any 3 variable Boolean function. Any 3 variable Boolean function I can implement, right? What about this? If you are having 2 to the power n minus 1:1 mux, then some n variable function can be made. Some n variable. Why is that so? Because you will not have this C bar. So you can certainly make 3 variable function, but the function that will involve C bar, that you will not be able to make. And if you are able to make the function that involves C bar, that means you are using AC as a select line, but you will not be able to make the function that involves B bar as a variable, right? And if you are able to implement that means you are using BC as a select line. So you will not be able to implement a function which will use A bar. So certainly one bar will be missing. So for that you need a NOT gate. If you are having a NOT gate and one variable less mux, you need to implement n variable, and you are having one variable less mux, then also you will be able to implement, but the condition is you should have a NOT gate. So if I am asking you the question, you are having 16:1 mux. You are having 16:1 mux. Can you implement all 5 variable functions with that? Can you implement all 5 variable functions with that? No. Why so? Because you can get only 4 inverters, basically A, B, C, D, and A bar, B bar, C bar, D bar. You will not get E bar. But if you are having plus 1 NOT gate, then can you implement? Yes, I can implement. So that's the thing. Okay. So in the example I will write just an example. 116:1 mux plus 1 NOT gate is equals to any 5 variable function. This is the first one. Second, 132:1 mux is equals to any 5 variable function. Why so? because 32 is to 1 mux will have 5 select lines. If there are 5 select lines, then I can get 5 bars. If I can get 5 bars, then I can implement any 5 variable function, right? Any 5 variable function. Third one, 116 is to 1 mux. Then you can write some 5 variable function and all 4 variable functions. All 4 variable functions. All 4 variable functions you can make. Okay then. So yeah, that's it. That's the complete chapter of multiplexer. And I hope you enjoyed the lecture. I hope you have understood every single thing in multiplexer. We will see an assignment, but before that we need to wait for one more video. There we will study about DMUX. So in the next video, complete DMUX will be completed, and after that we can solve one assignment. Okay. So let's meet you in the next video. There we study about DMUX. Thank you.